I'm going to talk about a few different antennas, three kind of primary antennas that I use for SOTA activations. I use three primary different rigs when I go up to a summit. If I want to pack small and light, it's a Mountain Topper MTR-3B with an end-fed half wave. If I want multi-band versatility, but something still nice and small, I bring a KX2 with an end-fed random wire. And if I want, some QRO, SOTA QRO operation, I'll bring a Yaesu FT857 with a linked dipole, since that can easily handle the power. So I'm going to talk a little bit about each of those antennas and kind of some pros and cons of each one. Because if you know anything about antennas, you know that every antenna is a trade-off. There is no perfect antenna. Really everything is just a trade-off between typically size, efficiency, and bandwidth. So I'm going to show a few pictures here. So that first photo is me with a loop antenna that I built, maybe another topic for another night. That's actually built out of some aluminum tent poles bent into a circle with a variable capacitor on it. And it tunes from 10 to 40 meters. Pretty cool little setup. I think it weighs about 12 ounces or so and sits on top of an upside down trekking pole, wedged in some rocks or propped up with some some string and stakes. So these are the three antennas that I want to talk a little bit about tonight. You can see the Mountain Topper up in the upper right corner there. It's about the size of a deck of cards to give you a little bit of scale there. And on the left hand side here, we've got a bundle of RG174 coax with a little common mode choke on it. And then the linked dipole. So this is a 40 through 10 meter linked dipole. It's made with 26 gauge wire, but you can see it's still a decently bulky antenna. The reason it's still advantageous for me is that it can easily handle 100 watts from the Yaesu FT857. It's a super easy antenna to build and really a simple top performer when it comes to just a simple, easy to build antenna. The one in the center here is one that I actually just put out a video on how to build that. I'm going to talk a little bit more about that tonight. It's an end-fed random wire with a very small 9-to-1 unun built right onto the BNC. And I typically build it with 41 feet of radiator and 17 feet of counterpoise. And that'll tune 60 through 10 meters, which are kind of the optimal SOTA bands. It'll sometimes tune 80. And I actually even built a version with a loading coil, so I don't have to string out too much wire and gain the ability to easily tune up on 80. And then the bottom right antenna is my super light end-fed half wave with traps for 20, 30, and 40 meters. So that's what gets packed with the MTR-3B. So again, I mentioned some advantages of the linked dipole. The biggest disadvantage of it out of these three really is just the bulk. You have to have a feed line with it, and feed line is typically the bulkiest part of your antenna system, at least for SOTA antennas. The advantage, of course, is the power handling capability. So let's see. I don't think I have any more specific comments about the linked dipole. Does anybody have any questions about the linked dipole? All right, let's take a look at.
Just a quick one.
Yeah,
Adam.
go ahead.
What are you actually using for the links, like to separate each link? What type of connector?
Yeah, good question. So on this build, I used some really small spade connectors. I think I've got some right here. Yeah, here we go. So these are tiny, tiny little spade connectors, and I use those guys as the links. This is the male version. There's a female version that it fits right into, and then for strain relief, I've got some nylon, real thin nylon cord with some heat shrink and super glue holding it together. But you can kind of hopefully see those spade connectors there. Not fully pressed together, but you get the idea. So these are nice and small and light. Some people use, just Anderson power poles or alligator clips. Those are some other options that are pretty common and easy to connect and disconnect. I guess one little disadvantage to the link dipole is to change bands. You got to drop your pole down, collapse your telescopic pole so you can reach the wires, and then push the pole back up in the air. Any other questions on the linked dipole?
How many links do you have, and you use like 40 and 15 for the same link?
I typically don't use, I haven't been using 40 and 15 for the same, but I should check and see if 40 matches well enough on 15, because it very well may. I've got links currently for 40, 30, 20, and 17 on this one. I have not yet added ones for the higher bands because I built this in the last few years since the solar cycle's been pretty low, so I didn't need the higher bands so much. So this one here is the micro mini end fed half wave that goes with the mountain topper. You can hopefully see on the scale there, 1.26 ounces for this whole antenna on the winder. It weighs practically nothing. It's some super cheap 30 gauge wire from Amazon, about $8 for a 1,000-foot spool of this stuff. It's so cheap. It's a single conductor and not very durable at all, but I've been using this thing for about a year and haven't had any failures yet. So it seems to work well enough. Let's see, this is another end-fed half-wave, very similar design, but this is with the matching unit built right onto the RCA connector that the older mountain topper MTR3Bs have on them. This one I sent up to, I think I sent this to either Rex, KE6MT, or AA6XA up in the Bay Area, and it's a 30-meter monobander. There's the matching unit for it. There's a F50-43. It's a -43 mix. I think it's a 50 size toroid right on top of the RCA connector. And we'll get into some photos here of exactly what's inside of that. One more trapped version. This is with still 30 gauge wire, but multi-stranded, a little bit more, slightly more durable wire. This had some clear heat shrink on the toroid on the BNC, so you can see inside there. So I originally got this idea for these end-fed half waves, looking at a crimped BNC connector and thinking, man, these toroids fit perfectly over the tops of these things. I wonder if I could come up with a way to build a matching unit right onto the BNC. So I started tinkering around, and I figured out, well, actually on the initial models, I built it with a regular through-hole capacitor. And in later units like this one, you can see the surface mount capacitor soldered in shunt across from the pin to ground. It's a 100 picofarad, just a ceramic, I think 500 volt or kilovolt capacitor. And slightly modified BNC connector. These ones that have this open window on the side, you can find by searching Amazon or eBay for solder window BNC connectors, and they're fantastic for these little projects. So here's one with the approximately 49-to-1 or 64-to-1 Ballon or Unun on top of the BNC connector there before there's any epoxy or coating on top. I'm actually putting together or editing a video right now that shows how to build this. I recently put one out on the 9-to-1 Unun for the random wire that's built in a similar way. And this one's coming soon. So here's the trap before it's put together. That's going to be part 2 of the video I'm coming out with to kind of show people how I build and tune these traps so that they're effective. This is a T37-2 mix toroid as an inductor, and that gets put in parallel with this little surface mount silver mica capacitor to make essentially just a little resonant circuit that presents a high impedance at a very specific frequency. And that gives you a means to kind of act as a roadblock for RF at a certain frequency and make the antenna look like it's a different length on that one frequency than it does on the others. So there's another picture of that that trap a little closer up once it's sort of fully built there. Another shot of a trap in the palm of my hand. So any questions about the end-fed half waves there and the design on those? Yeah, go ahead, Dave.
Yeah, I wonder what material that's from. A little the PC board you're using is from one of those little proto boards or whatever they call it, and you just cut it down to the size you wanted. It already got the eyelets and the holes.
Right, that's exactly what it is. I found that to be a pretty convenient way to build that trap, is to just hide that. Use a piece of that proto board or perf board and kind of Dremel it down to the size and shape that I want. Solder that surface mount capacitor on and fit it right inside the center of that toroid. And it,
yeah, very clever.
yeah, it works pretty good. And then I finished these off with some epoxy, 5-minute epoxy inside, just to make sure nothing gets jostled around or broken in use. I do the same thing with the matching units as well to reinforce them before I put the heat shrink on. One of the things I've found in tuning these traps is that you get an approximate tuning, figuring out the number of turns and your capacitance to get the resonant circuit, and then you test it with I use just an antenna analyzer, and I found that I can fine tune these by essentially like compressing or moving the turns on the toroid closer or further together. It kind of fine tunes the inductance and helps me get that perfect sweet spot of resonance just off the desired frequency for the trap. And to prevent that from moving and losing its tune, that epoxy and heat shrink really helps.
Here's a question from like a total beginner here. So essentially you have an antenna that's not really perfect for that frequency, and this device will in a sense trick the radio into thinking that it's matched to that particular antenna. Is that?
Yeah, so let me try to describe at least my understanding of an end-fed half wave and how that compares to, say, a linked dipole. And I would welcome Dave or Dan or anyone else with that are not mechanical engineers like me trying to sort this stuff out to correct me if I'm wrong. To me, an end-fed half wave is essentially just a dipole, but fed at the end of the wire instead of at the center of the wire. You may have also heard of off-center fed dipoles, which are also essentially dipoles, just fed further from that center point. And as you move away from that center point, your voltage and your current change. They shift as you move away from that center point. At the center of the antenna, you're at a voltage low point and a current high point, if I remember correctly. And you get a nice roughly 50 to 70 ohm match depending on how flat your antenna is set up. And as you move away from that center point, you get a higher voltage feed and a slightly lower current feed until you work your way to the end and you reach that voltage maximum and current minimum. And also, as you move away from that center, your antenna's feed point impedance goes from that roughly 50 to 70 ohms up to roughly a couple thousand ohms at the end of the wire. So we know our radios like to efficient. If you want to have an efficient transfer of power, you need to feed an antenna that has a nice 50 ohm match to match the output of the radio. That's what they're all just built for. So in order to take that 2000 ohm feed point impedance and make the radio happy with it, you have to transform that down to an impedance level that matches the radio.
No, that helps a lot.
Any comments on that to add to it or correct anything I said there?
Sounded good to me.
Yeah, basically
Cool.
you're trying to, like you said, match the impedance of the antenna to what the radio wants. So that's like it's just like a transformer, basically, is what these guys are that we're looking at there. And then, well, actually, these are actually traps, aren't they?
Yeah. So the transformer is at the feed point. The traps are a little bit different, right? The traps, essentially, from what I understand, act sort of like just really high impedance points or roadblocks along that wire for very specific frequencies. So to build the antenna as a multiband with traps, I'll first build it as, if I want to build it for 20, 30, and 40 meters, I'll first build it for 20 meters and get that first section, the right resonant length to match well with that, excuse me, with that matching unit. And then I'll design a trap that is essentially resonant on that 20 meter frequency that I want to use on that length. And by doing that, when I'm operating on 20 meters, the RF basically stops there and doesn't see the rest of the wire beyond that antenna. As I shift up to 30 or 40 meters, that trap just ends up looking like an inductor. It adds some, almost like some loading to the antenna. So it essentially kind of shortens the overall length of the antenna by inductively loading it. It ends up narrowing the bandwidth a little bit, so you don't get quite as broad of a bandwidth. But like I said, it does have that advantage of also giving you a slightly smaller antenna.
So Adam, what size wire are you using in the traps? And also, how critical is the tuning of the traps to the performance of the antenna?
Yeah, good questions. So the wire I'm using in the traps is just a standard magnet wire. I believe those are using a 24 gauge. It might be 28 gauge, but I think it's 24. And then the tuning of the traps is very important. These circuits are pretty narrow. The bandwidth is pretty narrow of their resonance. And from what I've read and from what I understand, you ideally want to tune them just very slightly off of the frequency that you want to be operating on for that band. I've seen people typically say to tune them slightly lower than the frequency you want to operate on. I don't fully understand the physics behind that, but from what I've been able to gather, you have a little bit slightly greater losses if it's tuned right on the frequency that you'd like to use. You end up with a little bit more losses there. If you're too far off the frequency, you're simply not going to block as much of the RF as you'd like. You're not going to get as high of impedance at that frequency and at that point on the antenna. So you may have SWR issues, and the wire you add after that trap may end up impacting your tuning of that first section. Any other questions on the end-fed half-wave? So I really love these end-fed half-waves. They're super efficient antennas. They function very much like a dipole. And one of my favorite aspects of them is that you don't need a feed line with it. I just hook this thing straight up to the connector on the mountain topper and go. I typically set it up in an inverted V type fashion, and I've tuned it and built it, with the relatively small, lightweight. I think it's about 12 feet telescopic pole that I often use with that lighter radio system. So So it's tuned properly to when it's set up, that low to the ground. One thing you'll find with really any antenna is that the tuning varies a little bit. The higher it is from the ground, the lower it is to the ground, the lower the resonance is going to shift, and the higher it is above the ground, when you're still relatively close to the ground, it typically shifts the resonant frequency slightly higher.
Hey, Adam?
Yes.
The one you have the 64-to-1 on there, what's that antenna? What does it perform on?
I'm sorry. You said the 64-to-1. So one of the other photos, was that what you were looking at?
Yeah, you had a 64. So the 9-to-1. I know what bands that works. What bands does the 64-to-1?
Yeah. So the 64-to-1. Let's see if I can find a good photo here. Here's a picture of the 49-to-1 or 64-to-1. That's what you use for any of the end-fed half-wave antennas. So because you're feeding at the end of essentially at the end of a dipole, your feed point impedance of that wire is going to be 2,000 to 4,000 ohms. So you need to bring that down to 50 ohms. So you need a very large ratio transformer.
Okay, gotcha. So the 9-to-1 is for like quarter wave, right?
The 9-to-1, we'll talk about that in a minute, but I use that for the end-fed random wire, which is of course another really a compromise antenna for some other reasons. So good questions, Chris. Let's take a look at the 9-to-1 and better answer those questions. So here we go. That's the trap. Here's the 9-to-1. So this is the antenna that I typically carry with the KX2. The KX2 has a built-in tuner, and excuse me, as Dave mentioned, he likes to carry the KX3, which has a very similar built-in tuner, if not the same one, with just a banana plug setup and a 53-foot length of wire, probably with a counterpoise. And that tuner in those radios is pretty impressive. It can handle a lot. And I imagine he's able to tune up on probably most bands with that. So that's your 10 meter band up there on the right, the fat blue bar on the right, 12 meter, 15 meter, 17, 20, 30, 40, and 80 meter. This doesn't show the 60 meter band on here. So this is the 41-foot radiator and 17-foot counterpoise hooked up to just a BNC to banana plug adapter directly to the antenna analyzer. I wanted to compare what those exact same pieces of wire and the exact same setup look like on the analyzer compared to when I hook that up using the 9-to-1 unon. So take a mental snapshot of that, and then let me know when that loads for you.
What kind of VNA are you using?
This is, what the heck is it? It's, I'm brain farting on it. AA35 Zoom is the model number. Rig Expert
right.
makes it.
Just changed.
All right. So what you can see here is that for the most part, the SWR we're working with here is less than 10-to-1 across all the bands. So one of the keys with operating a random wire is that you're always going to be using a tuner with it. You're going to need a tuner either in your radio or outside of your radio to bring the antenna into resonance. And one of kind of the misnomers with a random wire is that it's not random at all. There are actually certain lengths that are ideal for a random wire antenna, and really your goal in selecting those lengths is to pick a length that's not resonant on any of the bands. And if you do that, your tuner is much more likely to be able to tune it up on all of the bands that you might want to operate on. So in
A quick comment to go with that, Adam.
Yeah, go ahead.
I've read also that your wire ought to be, I think it's at least 2/3 the length of a half wavelength at the lowest frequency you want to use. So I think that's why that NorCal QRP antenna with a computer wire is 44 feet long, because it's 2/3 of the 66-foot, 40-meter half wave.
That makes sense. Yeah, I've heard something similar. I think what I've heard is at least about 3/8 of a wavelength. So when you do the math, it's about the same.
Right. Yeah.
So yeah, that's an excellent point. So it can be too short, as you see toward the lower end of the band here, where the SWR just goes way up off above 10-to-1 there. So you guys are probably well aware at this point that the amateur radio bands are sort of multiples of each other, right? 10, 20, 40, 80. So if you end up with an antenna that's resonant on the 20-meter band, it's going to give you a very high SWR, really poor performance impedance match on 40 meters typically. The multiples of the bands just typically don't get along well. So that's kind of, I think, the idea behind the end-fed random wire here, in selecting that non-resonant length that gives you an impedance that's matchable on all the bands. And you make that easier for your tuner by adding that 9-to-1 transformer. So we saw in the previous picture of the analyzer here that our impedance was pretty darn high across, well, we saw the SWR was high. If I showed you the actual impedance, you would see that the impedance was relatively high across the board. If I transform that down with that 9-to-1 un, it essentially makes that antenna easier for the tuner to match. Any comments on that, or nuggets of information that anyone wants to add?
Well, maybe just to sort of quantify what you just said, if your antenna, whatever length you've chosen, if it's, say, as you sort of said earlier, between, say, 1,000 and maybe even 4,000 ohms, the transformer that you're using will maybe bring it down into the, if you're lucky, as low as 50, but it might bring it into the 100 to 400 ohm range or something, and maybe that is low enough for your tuner to actually be able to make a match to 50 ohms for the output of the radio. So thinking in sort of that, just adding that little sort of nugget of info.
Yeah, and that's exactly, I think, the idea and the point of oh, nice, my internet connection is unstable. I think that's the point of that 9-to-1, like Dave said, is that it brings that random wire down to a point where your tuner can handle it. So in a similar way that I did with that end-fed half wave, I thought, well, if I can build an end-fed half wave matching unit on a BNC connector, I can just as easily build a 9-to-1 on a BNC connector. So here's, like I said, the antenna I typically carry with the KX2, about 1.25 ounces, and the BNC with the un on it right there. Here's a close-up view of one of those 9-to-1 ununs. I end up making about 8 or 9 trifilar turns. So there are essentially three sets of 8 or 9 turns. And you can see in these two BNCs at the top here, you can see the epoxy in those that helps secure those into place. Excuse me. And then the bottom RCA jack one down here is actually that end-fed half-wave example that I showed you before, but without the heat shrink on it. You can see the epoxy in there as well. So there's a batch of them. I've had some requests from friends. Hint, hint, Ed. One of these is coming your way.
Okay. Be honored.
So I've been trying to build a few batches of these to share with others. So pros and cons of these end-fed random wires. Well, the pros, of course, are that if you've got a radio with the tuner, you can pretty much tune these things on any band, and they're incredibly fun to take up to a mountaintop and sit there and monitor SOTA watch. And somebody comes up on 60 meters in Arizona, you tap the tune button and you work them. Somebody comes up on 20 meters in North Carolina, you hit the tune button and you're able to work them. It's just any band you want at the push of a button, and the performance is decent. Not as good as an end-fed half-wave or a dipole. You definitely, I think, sacrifice a little bit of performance with these. I think there are just some efficiency losses in the tuner and the transformer that you just, you know, it's part of the game when you want that versatility. Other drawbacks, well, you have to have a radio with a tuner to make these work. If you don't have a tuner with your radio, or you don't want to use a tuner with your radio and carry that extra weight, this antenna is not going to do you any good. Power handling capacity on these is probably going to be pretty similar to the end-fed half-wave. I wouldn't want to put more than probably 10 watts through these things, and 10 watts might even be pushing it. Quick note on these, the toroid mix, I don't think I mentioned. I use a -61 mix on the end-fed random wires. I find that works really well, and it supposedly gives a little more efficiency. Excuse me. I use the -43 mix on the end-fed half-waves. I've tried the -61 mix on the end-fed half-waves, and I found that it results in a more narrow-banded transformer that doesn't work well as a trapped setup. It'll work as a monobander, but it doesn't work as a multi-band for links or traps. So those are my 3 primary SOTA antennas. And Chris, let me go back to you. Did I answer your questions on the 9-to-1 UNUN and the random wire antenna?
Yep, a lot more making sense now. Thanks, I appreciate it. One other question. Somebody told me that having your matching unit, your UNUN, right at the feed point where your radio is at, there's a little bit of an advantage of doing that rather than having any feed line in between. Can you comment on that?
Yeah, that's definitely true. Anytime you have an impedance mismatch from coax to an antenna, you have greater losses in the coax when your tuner is not at the impedance mismatch. So if you're using coax with the 9-to-1 like that, you've got 50 ohms at your radio. I assume you're connecting 50 ohm coax that runs, say, 30 feet to your 9-to-1 UNUN, which is your impedance mismatch location. Your tuner can still work that out at the radio, but you're going to end up with a bit more losses in the coax. And you can actually, if you go to an online coax loss calculator, one of the things you can typically plug in there is an impedance mismatch, and that'll help you gauge, I think, coax losses based on those mismatches.
Yeah.
All right, thanks.
One more question. I noticed, like, I've used the Elecraft AX1 little antenna that's like the vertical whip that they have that you can plug right into your radio. And I noticed when I'm using that, you kind of, in a sense, you might be detuning the antenna with your body because that you're so close to it. So have you any experience with that with these? In fact, that the antenna is like right next to the radio. Would there be any possible losses there that you could speak of? Or
Yeah, they're having you close to the antenna, or even just having the antenna close to the ground or not close to the ground, will impact the tuning of the antenna. So you have to be careful with that, and you have to pay attention to how you set it up, and how you initially tune it, to make sure that you, especially for the resonant antennas, that you tune them in the same orientation and setup that you're going to be using them. So one example I would say with that is that I typically operate my mountain topper MTR3B sitting down on the ground, holding the radio in my left hand and tapping away at the key with my right. So I set myself up in that position when I'm tuning an antenna for that radio, so that it, the antenna is set up in such a way that it's built for kind of optimal tuning for the way I'm going to be using it.
Gotcha.
Yeah, one comment. I'm not sure. I've seen pictures of this AX1. That's the loading coil vertical that mounts directly on the radio, right?
Right.
That's a quarter wave vertical with a lot of loading, is it not?
Yeah,
Right.
and then there's like a 17-foot counterpoise, but they also sell a quarter 20 female threaded little plate so that you could put it on like a tripod or some other device and get it away from you. And then so they have that way to mount it, or you can have like a little right-angled BNC to mount with a little bipod, and you can mount it right to the radio itself. I've heard from people that have used it that it's better to get it away from you and up as high as you can. But I've only tried it a few times and haven't really tested it too much.
All right. Well, I don't know if it's rule of thumb is really the way to put it, but an antenna has to be technically at least a half wavelength away from anything, ground, your nearby objects, before it starts to behave more or less the way it's designed to behave. And if I'm sitting under my wires 20 feet off the ground, and I've got the feed line, well, it's actually just part of the wire coming off the second pole or whatever I've tied it off to, coming down to the radio. I actually stopped using a counterpoise because I found that it seemed as though my RBN spots were weaker. And also a friend of mine who knows a lot, he kind of chuckled at me. He said, well, any wire on the ground is not radiating. But my point is that, our proximity, we just become part of the whole antenna circuit. And so, as Adam's saying, he's tuning while he's including himself. And you can kind of experiment with this too, that when I've noticed that, say, on 30 meters or 40 meters, which is pushing the length of my wire, I can detune, I'll tune to the tuner. And then when I touch the metal contacts of the paddle, I notice that my SWR is different. That's because I'm part of the loop. So
Gotcha.
Just something to keep in mind.
Yeah.
I guess the other comment about, you made very good points about the coax. Coax isn't designed to be tuned, so to speak. It's really just taking what you put into it and sticking it out at the other end. So ideally, what you're putting in at the end of one end of the 50 ohms coax is 50 ohms, so that what comes out is 50 ohms. And if you don't do that, then you end up with problems. And coax, I remember seeing in the, I think it's the Doctor is In column in the ARRL in QST. I think I've seen it more than once, where somebody goes through and shows you, if you take an 80-meter dipole or a 40-meter dipole and you use it on different bands with a tuner, but with a coax feed, these are your losses, and they're horrendous. So, and it's just because you can't really make the radio from the coax, where the coax goes into the radio to where the coax goes to the antenna. That's a no man's land. You can't really fix that. That's why you need to come up with either matching at the end of the coax where the antenna is, or using a different kind of feed line.
Use ladder line. So I have a question for you, Adam. First of all, you're very radiant, so I'm sure that's why your antennas work pretty well with you. So, but on your trapped half wave, end-fed half wave, it's much shorter than a 40-meter half wave. That would be a monoband. Have you looked at how well your trapped end-fed half wave performs versus just a 40-meter monoband half wave? That's full.
Yeah, no, I have not done any direct comparisons. And one thing to note is that you have some flexibility when you build your traps in how much inductance you put into them, right? Because you can make a resonant circuit with an L and a C with different values of L and C that are resonant on the same frequency when you put them in parallel. So, so I've designed some of those antennas for some people that wanted a shorter, a more loaded antenna, shorter overall antenna. And I built other ones. The one that I built that I showed in the photos. I don't think I want to say it's probably about 55 feet long, maybe 57 feet long. So it's not that shortened over a full length 40-meter end-fed half wave. So I kind of tried to strike that balance of not having too much inductive loading on there to take my bandwidth down and lose some efficiency.
Thanks. I've seen some other designs that were maybe half the length of a regular 40-meter.
Oh, wow.
Got a lot more inductance. And I always find that the more copper you have up in the air, the better performance that you have.
Yeah. Yeah, and it's interesting. The MTR3B antenna and the random wire antennas that I use with the KX2, I'm typically using 30 gauge wire. So I know you were generally referring to length of wire up in the air, but I have not really found that the lighter gauge wire seems to really result in significant losses. Then again, I haven't done any calculations or measurements on that. I just know that I'm still making contacts with it. But I'm sure you guys know you can make some decent contacts with some pretty crappy antennas sometimes too.
Well, you got some really low currents there, so your I squared R should be really low, so it should be an issue.
Yeah, and there's a lot to be said for that low noise floor on a good summit. So the summit to summits are magic.
Yeah.
Indeed. All right. Any other questions? And if not, I'll go ahead and wrap up and pass it back to Mike.
It's really good, Adam. Thanks.
Cool. Well, thank you guys.
Yeah.
I hope you enjoyed.
Yeah, thank you, Adam.
I second that.